I think we should be good now. God damn it, it's been a long fucking time. Alright. But anyways, we're going to get started. It's not OpenGL, unfortunately. Although I do want to do some stuff for OpenGL in the near future. I'm still working on that stuff. I've just had a lot of complications. I can definitely talk more about that in another stream, but I will clarify that later on. Give me 2 seconds, I'll be right back. I just had to close my door. All good though. Alright. Looking good now. Alright. So yeah, today we're going to be doing another programming challenge. And we're actually going to be looking at Winsock programming, or networking in C, not C++. We could use C++, but I kind of like gravitating towards C for some reason. Just because C is technically considered lower level than C++. But anyway, we can go ahead and get started. Alright, so what is Winsock programming? Well, like I said, it's an API. It's abbreviated with WSA, and it's an API that allows Windows programs or exe files to kind of communicate using the networking functions of computers through the Windows operating system. So what this entails is we have a library which has header files, which gives us structures. They're all structures, no classes, since this is in C. And we have structures for to represent clients, servers, functions on how to communicate with all of them, how to initialize sockets, and all that stuff. So we're going to be walking through a lot of these functions, much of the structures as well today, and then we'll be creating a server as well. So today we're going to be looking at how to create a socket listener, or more commonly known as a server, and then we're going to be using PuTTY as a client, which is just a bare bones communication client application that you can customize easily. It's an application. I put a download link to it in the description. Alright, another requirement is you obviously are going to need GCC or any C compiler that has the WS2 or the Winsock libraries. Alright, so let's start with main.c. So in main.c, we're going to do a few things first. We're going to be using the Windows library, so we have to kind of consider which Windows files we have to include from the Windows SDK. And we're going to start by defining something. So if not defined, win32 lean and mean. Then we're going to define win32 lean and mean. Now, what in the fuck does this mean? Well, and then we're going to end if. So what this is it's a preprocessor directive for the, or no, that's the wrong word. It's just a macro for the header files that will give us a kind of a more consolidated version of the Windows SDK, and it doesn't have all of the files that certain APIs may not use. So for example, Winsock, the WSA Winsock API only uses header files from the win32 lean and mean definition, and if you were to expand this in the Windows SDK, you would get an include of a bunch of other files. So we're going to be using this consolidated version, and we're also going to want to include a few other files. So we're going to include winsock2.h, include windows.h, include ws2 tcp/ip.h. So this is just a TCP protocol header. The Winsock is just the WSA header. Then we are also going to have include IPH LPAPI.h. So this is a header file that has to do with IP addresses, I believe. And then we're going to include stdio. Now, since we are only using GCC and we don't have a linker with us, what we're going to have to do is we're going to have to kind of link the library using the pragma preprocessor directive. So we're going to say hashtag pragma, and then we're going to do comment. Then in the arguments for this, we're going to say lib for library, and the library name will be ws2_32.lib. So this is the library file that has the Winsock libraries associated with it. And then some other stuff that we're going to do before writing the code. We're going to have a few macros here. So define buff length, bufflen as 512. So this is just going to be the length of a buffer that we have. So that's going to be the message length that we can send and receive. We're going to have a hashtag define port as 27015 and hashtag define address as 127.0.0.1, and this is just localhost. So yeah, this is just another aka localhost. All right, so these are all the macros that we're gonna have to deal with. Once again, so the lean and mean stuff tells the compiler which Windows header files to include, because when we include windows.h, it's going to look for which macro is defined, and in windows.h, if this macro here is defined, then it's going to include a certain a more consolidated set of header files. All right, and then we have our header file, other header files here, and then for the library to do something special in the GCC. So let's do in main for our main method, and then for now we will just do a printf hello world and return 0. Let's try running this. First, we have to write our command script. So we'll only do a run, but we can easily do this as a debug as well. So we're going to do gcc main.c, and then I'm going to do -o for generating an object. Object will be server, and then since we have libraries that need to be linked that aren't default, we're going to have to do -l and then ws2_32. So this is the library file that is in the GCC library path, and it is the Winsock. And notice how this name matches up here with this. All right, then we can just go ahead and run that server, and then pause, and CLS. All right, let's do this CD 29.1. All right, hello world, perfect. All right. All right, I also want to try something with PuTTY, but I'll do that once we actually have some server code written. All right, so the first step is we're going to do is we're going to actually initialize we're going to configure the WSA library, or just the Winsock API. So what we have to do is we have to get a structure, WSA data, in all caps, and then we're going to name this just WSA data. You can do whatever. So this is the configuration data. So once again, we are doing the initialization. So today we're only going to be working in a main method, but when we do some more complex stuff, I feel like we're going to organize it into structures. We'll organize it possibly into threads if we want, and then we can also do separate methods as well. All right, so for the initialization, we're simply going to call a function, WSA startup. We're going to call the version, which is a word, and this we can generate a word using the make word function. So make word and pass in two arguments, 2 and 2, since we're using version 2.2 of the WSA or the Winsock library. And then we have to store the data somewhere using a reference to WSA data. Now WSA startup returns an integer, and we want to store that integer in a result value. So int res, we can just have that up there, and then res is equal to WSA startup, and res will have a value now. So if res, if there was an error, so we're going to say printf startup failed, and then we will just print out the value of res, and then return 1. Right, and then at the end, we're going to do something similar. We're just going to say WSA cleanup, and that just cleans up the library there. And then we can also just say res is equal to this, and then say if res, then cleanup failed. All right, so let's go ahead and run this again. Yeah, all right, so no errors were encountered. Perfect. All right, so now we are simply going to be working in between these two blocks. So we have the initialization block, which is up here, and then I'll also just section that off. And then we have the cleanup block as well. All right, now we're going to actually be starting to look at the server structure. So one thing that is going to become clear is that all the server and the client in WSA's eyes, they are simply the same thing. We're going to treat both as a socket, because that's simply what they are. They can send and receive info, but they are in the most basic level, they are both sockets in a network. That you can think of it as a power socket. You can plug stuff into it, you can connect lines to it, and then you can send electric signals through those sockets. So the difference is what we attach those sockets to. So for our server, the socket will be attached to a listener, and it will be bound to listen to a certain IP address and port, or a certain port on the IP address that we pass in. So that will be the main distinction, and then a client that is going to be the other way, where the client is connected to some IP address, but it is not bound to listen to it. All right, so we'll start by constructing our socket. Set up server. So we're going to start by creating our socket. So sockets listener, and listener is equal to socket, and then we're going to have the AF is just the I forget exactly what the argument is. Give me 2 seconds. AF is just the address family. So for today, we're going to be using AF INET. And INET as is, not INET 6. That just defines like the type of address. So something in INET would be 127.0.0.1, whereas INET I forget exactly what INET 6 is, but it has hexadecimals in it. INET 6. Oops. Yeah, so INET is IPv4 and INET 6 is IPv6, and that has many more values to it. So AF INET is going to be the family, then the type will be a sock stream, and then the protocol will be TCP. So IP proto, then underscore TCP. And that's just this is just the standard protocol that we're going to use today. And then once again, this function will return a value, and it's going to return a socket, which is also just an integer, or a pointer rather. But it will return an invalid socket. It could return, so if listener is equal to invalid socket, then we're going to say printf error with, and then print out an integer, and the integer will be WSA get last error. Alright, so then if we encountered an error, what we also want to do is just clean up. So WSA cleanup, and then return 1. Alright, so we have set up the socket, and now so we're going to bind to an address. So first we need to create the address structure, because when we bind it to an address, it's going to be looking for some a structure pointer that contains the info of both the IP address itself and the port. So the address will be a struct sock addr for struct address sock address underscore in, and it's going to be called address. And then address dot sin underscore family is equal to AF INET, the same as above. Address dot sin underscore addr, then this dot s underscore addr is equal to INET underscore address, and the address that we're going to pass in is the macro we had defined above, so address, just like that. So this here is the macro we have up here. So we're simply passing in the string value to this function INET address, which takes in a string and returns the numerical value that we want, or that the computers can use. Because this string here means nothing, but once converted to a numerical value, it can actually use it then. All right, and then we're going to set the port, so address dot sin port is equal to h2ns. So this function here, h-t-o-n-s, takes a host byte order port, so a number simply, and gives it into the network byte order. So that's the H for host, and then network byte order short. So HTONS for the function, and then we're going to pass in as the argument. All right, then we want to bind to this. So we're going to call bind. The socket will be listener. The sock address will be a structure sock address pointer conversion of a referenced address. So we're going to take a referenced address and then cast it to a struct sock address. And then this, and then the third argument will be the size of the address, just the number of bytes there. And then it returns a value, so we can say res is equal to bind, the result of that, and then if, then we had an error. And you can just print something out as well. So print bind failed with an integer argument, and that integer argument will be once again WSA gets last error. Alright, and then here we have to now close the socket first. So close the socket and pass in listener, and then WSA clean up, and then return 1. So this error checking here that we is going to be this is going to be, we're going to see this several different times throughout this video and the next few videos, or the next video. Alright, so we have now bound the listener to the address, and then we have to actually set the mode as listen. Set as a listener. So we're going to say res is equal to listen, and the socket will be listener, and then the second argument is a backlog. So I'm just gonna put this here, and then I'm gonna explain it. So it's going to be the macro so max con. So let's look at this function. So this function sets the mode as listener, or the mode of this listener socket to listen to this address here. So we have bound it to the address, and now we want to listen to it. And then so max con, this is for the maximum connections. And the backlog is simply the number of pending connections that we can have before we just start refusing altogether. So I believe this number is I don't even know. I'm gonna be honest with you. It takes an integer, and I don't think that is not it's just the maximum. Is that an integer? I don't even know, I'm gonna be honest. I feel like that's a long, I'm not sure, but it's just the maximum positive value in an unsigned integer or long, whichever it is. So it's just the maximum value. And then we can also and then once again we'll have an if here. So if res is equal to socket error, then we're going to print listen failed, and print out the integer as ws gets last error, and close this socket, then WSA cleanup, and then return 1. Now we are listening, so we can print out printf accepting on %s or string argument colon integer argument, and we'll pass in the address and the port. All right, so let's run this, see if we just successfully get everything. Or before this, let's actually figure out the cleanup part for the server. And it's simply going to be so we're going to shut down the server socket, and that's simply going to be done with close socket with listener. And then I'll just put a comment here. And we can print out a few messages. So printf shutting down, good night. So yeah, we added the one line to cleanup, and then we also had this, and I'll go over this in 1 second once again, but let's just look over here. Hello world, accepting there, and then shutting down good night. Perfect. So far what we have is we have an initialization, that's up the WSA library. Then we have our server setup, which first constructs a socket. Now this is just a general socket, so it just takes in family information, the type of the socket, and the protocol. Then we're going to use this general socket and specify it as a listener. So we first have to bind it to an address using address info here, and then calling the bind function. And then we need to set it as a listener using this function here, listen, and then now it's accepting on that IP. So now, let's go ahead and handle a client. Handle a client, a singular client. So we first have to accept the client. So we're going to have another socket for the client, and then client will be equal to accept. We're going to accept through the listener socket. So listener is the first parameter, and then we're going to have null and null for the two other parameters. Alright, so now we have a client, and if we wanted to get the information, we would need two additional values. So we're going to need for the address length, and then we're going to have a struct sock address client ADDR. So this is very similar to what we had for the server right over here with this, but it's just different name. And then now we're going to get the information. Well, first we can check for an error on the accept. So if client is equal to invalid socket, we're going to printf could not accept and print out an integer, which is going to be, once again, WSA get last error. Then we're going to close the socket for the listener. WSA cleanup, and the return 1. Alright, then let's get this information. So get the client info. So we're going to use the function get peer name. And this takes in a socket, and it will output the IP address and so on and so forth to the value, the structures that we pass in. So get peer name will take in the client socket, and we're also going to pass in for the sock address name. We're going to a reference to of address to a struct sock address pointer. So similar to how we did over here, we're going to cast client ADDR to that. And then for the length of this, we're going to cast a reference length. So this is an integer pointer, and then we want to cast this to a sock len underscore t pointer. Or I think we could just, I'm going to try leaving it as that, as just a reference, an integer pointer. All right, now let's print out. So printf clients connected at %s:\d. And I'm going to pass in, I want to pass in the IP address and the port. So we could say address.sin address and address.sin port. However, these are not the values that we want to see for an IPv4 address. So we're going to need to convert these values into a string and an integer. So for the address itself, we're going to use the function inet_NOA. So N2A is essentially the opposite of inet address that we had above. It converts a numerical value, a numerical address, into a string that we can have. So N2A, and it takes in the address.sin address, and then we're going to say NTOHS for the port. So NTOHS, this is N2HS, which takes a network short and pass and returns a host short. So these are simply the opposites of the methods that we had over here. So inet address and H2NS. These are just the opposites, where we take a number and convert it into a string value, a value that we can read and we're familiar with. All right, so once we've gotten the client information, we want to send a welcome message. So we're going to have a char star welcome is equal to welcome. And we'll put a smiley face, and then we can say, we'll also have a result value for, a send res result value as an integer. All right, so we're going to send this. So res is equal to send so we're going to send it to the client. So the client will be the first parameter. The buffer will be the welcome buffer, and the length of the buffer will be the string length of welcome, and then 0 for the flags. Now this function will return the number of bytes that were sent. So we're going to say, we just want to verify that it was sent. So if send res does not equal the string length of welcome, then we have an error. So printf error sending and print out an integer WSA get last error. Then we're going to shut down the client, and the mode that we want to shut it down is SD both. So this is socket descriptor underscore both, and this will shut down both the sending and the receiving functions of the socket descriptor. And then we're going to close the socket client. Alright, so we have our welcome message, and we sent that out. And I guess we can just test this real quick. But first we have to shut down the client. So we're going to say res is equal to shutdown client on both channels, so SD both. And if res is equal to error, then printf shutdown client shutdown failed, and print out an integer as WSA. Oops. Get the last error. Then close the socket, the client sockets. Then WSA cleanup, or not yet, and then we'll just go beyond that. All right, so let's run this. Well, I mean, we're going to want to close this socket, the client socket, either way. So we can just put that outside of the if statement. All right, so let's run. All right, so we see that it is accepting on 127.0.0.1 at that port. So we're going to go PuTTY, and on PuTTY, what we're going to do is, I don't know if you guys can see this. Maybe I can try this on a different command prompt here. So does PuTTY? No, it does not. Okay. All right, let's try going to the PuTTY directory. So cdc/program files /PuTTY. Ah, okay, here we go. And then we can say PuTTY -load, or sorry, not that. Where is it? PuTTY command line. All right, so we're going to do PuTTY, and then we're going to do a raw connection, so -raw, and then for the host, we're going to do 127.0.0.1, and then colon, the port is 27015. Aha, here we go. Connection refused. Let me try this here. All right, so I'm just going to save this configuration here, and then we're going to do that, and then open. Ah, here we go. Perfect. So that worked. So you see in this PuTTY command line window that I mean it's probably pretty small, but you can see that the client connected. So in the server's command line, we see accepting there, and then client connected, and then in the PuTTY command line, so this is the client here, it says welcome to the server with the smiley face, which is exactly what we sent as the welcome message. And then we shut down the connection, which is why we're getting connection closed by remote host. So click OK, and then exit out the window. And then it said shutting down and good night. Just like that. Perfect. All right, so good. We have successfully sent stuff to PuTTY, or to the client. Now let's try receiving stuff from the client, because in PuTTY you can also type stuff in and it will send it as a raw message. So we're going to do a loop here. So after we send the welcome message and before we shut down the client, we're going to want to say do, and then we'll have a while loop. So while res is greater than 0. All right, so then we're going to say res is equal to the, we're going to take the result of the receive function. So res is equal to recv for receive, and then we're going to receive from the client socket. The buffer that we're going to store it in is the receive buffer. And we have not constructed that yet, but we need to. So we're going to have a character array. So character, and let me just make sure I'm doing this right. So character receive buffer array of length bufflen, which is the macro that we had above, and then integer receive buff length is equal to bufflen. So we're going to say do, and then we're going to have this receive. We're going to receive from the client, store the message in the receive buffer, and then the length of this will be receive buffer length, and that just tells the server how much of this message we want to receive. So receive buffer length will be 512, or we'll set it to. Yeah, 512. And this is more advanced stuff, or kind of a side note, but this is, since we have a finite limit here, what if we have a larger message? Well, this is where network blocks and kind of packets come into play, where we will accept blocks of a message separately and then put them back together in order to get the whole message. And then for flags, we will have. Now let's do a little thing here. Let's test to see, or let's try message back. So we're gonna have a few possibilities here. So if res is grid, then we're going to print out the message. So printf message received, and we'll print out a string. And the string will just be receive buffer, or the buffer. Now let's try determining if this message could be a quit message. So let's just, for like our sake, let's do a little command kind of thing here. So if, now we're going to do a memory compare, not a string compare, because memory compare will allow us just to compare like the first 5 characters, whereas a whole string, there are a few escape characters that PuTTY includes that would kind of screw up some of this. So we're going to say if the memory compare, and the first buffer will be the buffer, so receive buffer, and then we're going to have a quit command, which is just /quit as a string, and then the size will just be 5 times the size of a character. So if not the memory compare, so if this is equal to 0, then we have received a quit command. So we're simply going to say printf closing connection, and we will then break. And otherwise, we're going to echo the message back. So we can simply just say send res, so the result of the send is equal to send client, send to the client, the buffer now be the receive buffer. The length will be res, which is res stores how many bytes we actually received of, and that has a maximum value of this buffer length here. And then 0 for the flags. And then we're going to do another check here. We can actually just say, copy this check here for if send res is not that. So if, but this time we're going to say if send res does not equal, or if send res does not equal res, then we have then it didn't send everything, so we're just going to close everything out, and then we will also break. Alright, now there's another condition here. So we have if the result is greater than 0, then we have a message. Then else, if not result, then it's going to be a closing connection. Client disconnected. So we're going to print F closing connection. Like that, as simple as there. And then we can also just break. Now else, it's going to be an error message. So print F receive failed, and we'll print out the integer as WSA get last error, and close the client socket. Or I think we do that out there. Yeah, we do that over there. And then we will Alright, so this is our main loop pretty much, and all it does is we get the message. If there is a positive number of bits or bytes, then we print out the message, determine if it's the quit command, and then echo the message back. Otherwise we're going to close the connection or fail to receive. So let's try this out. Alright, so for the server, we're just going to do the run batch file, so accepting there. Now for PuTTY, once you're in the directory, you can use the PuTTY command, if you create a configuration, so if we do the save thing, you can kind of just say PuTTY -load and then the name, which I called home. Alright, so you see it opens up here. Can I zoom in? Oh. I can't really zoom in, unfortunately. So I'll kind of narrate. I guess it pasted something, but it received messages, which is good. So message, so I'll type in hello, and we see that it received this. Hi. What is going on? Let me try restarting this. Alright, so welcome to the server. Hello. Oh, you know what I think it is? It's not. Oh, yeah, I forgot to do something quickly. Hold on. Hold the phone. Hold the phone. Let me figure something out. Let me print out the result of send here with the string that we have. Okay. So res is the length of the string, and it may not always character at the end. So what we have to say is receive buffer at res is equal to a \0, just as the string terminator. So now, when we run this, and then say hi, we get hi. And then what's up, and we get what's up. Perfect. And then what you'll also see is that it echoes the message back. So I type in hello into PuTTY, and it will print it back out for me. Now that's not just PuTTY doing that. That is the server sending the message back. And then let's try the quit command, so /quit, and it says software cause connection abort. Click OK, and we're all good, shutting down good night. So message received 5, quit there. Now let's try closing the connection on PuTTY's side, and same thing happens, closing connection, shutting down good night. Alright, so that's that. Alright, so that is the singular client version. Alright, let me just figure out a more efficient way to do this, because in connection to why I haven't been too active recently, I don't really have a laptop with me right now. Just funny thing. So what I'm gonna have to do is get the chat up on my phone, and I'm gonna have to do that. Studio. Please work. Aha! Alright, I have it worked. Wow, that is taking longer than I thought. Alright, that's fine. Alright, what matters is it all worked out. Alright, so I have the chat up so I can actually look at that. I have not been looking at that at all, which kind of is bad. Alright, so pretty cool stuff. And alright, so yeah, that is the one client version of this. Now we're going to look at how to do multiple clients, because I mean, if we wanted to say run the server, let's load up PuTTY once, let's load up PuTTY again, and it doesn't work. Now, notice how it doesn't say refused, because this client here is in the queue of, it's in the backlog, so it's in the queue of connections. So let's try doing something. Let's close out of PuTTY here, stop the server. Let's try setting the backlog of the server to 1. So let's run the server. Let's have a connected client, so we see that the client is connected. Then we're going to have 1 go in the queue. So this client right here is in the queue. This is in the queue. Now again, and alright, yeah, connection refused, because this one right here is in the queue, and that queue, the maximum size of the queue is 1, so we can't have anything else in the queue, so it just starts refusing connections. Now the reason why this client is in the queue, and now if I close that one out of the queue, so we could open up another one, and this is in the queue, but it also says refused for some reason. But the reason why it's in the queue is because we only call accept once. We don't call accept several different times or on a loop. So we can only accept 1 connection every time we run the server. Now that's not very practical, as you can imagine. We're definitely gonna have multiple clients. Say if we want to do a chat application, HTTP server, a video game, servers on any server, there is not a server in the world with any practicality that has more than 1 connection, unless it's like some super secret crypto shit that we don't even know about. Maybe we could create something like that. But yeah, we're gonna be looking at multiple connections now. But first I gotta go get some water, so I'm going to die of thirst. I'll be Yes, I'm back. All right. So Alright, so we have our main file, and this is single connection. Let's now try, I'm going to copy this file because it's going to have the same structure. No, not that, paste. I'm going to call it main underscore multiple. Now for main multiple, we're going to keep initialization. We're going to keep setting up the server, although we do have to have one extra thing. We have to set up a switch. Handle a client, this whole section here is going to be deleted. Or, I mean, we can keep some of it. No, I'm not going to touch it right now. We'll walk through it. But there are parts that we can keep, or that we're going to see at least. Alright, so when we're setting up the server, we're going to want to have a switch here that wants to handle multiple connections, and that's going to be the reuse address switch. So it's going to be an option actually. Before we bind it to the address, and once we've constructed it, we want to set up for multiple connections. So we're going to have a value. So we're going to have a character. Multiple is equal to not 0, so not false, which is just true. And then we're going to say res, the result is of set sock opt, so set sock option. The socket will be listener. The level will be SOL socket. And let me just figure out quickly something about that. Alright, so this is the level of the socket, or the level of the option, and it's just going to be SOL socket, so it's just SOL is just option level, and it's going to be the socket as the level. Not entirely sure what that means exactly, but that's fine. And then the option name will be SO underscore reuse address. So that's just the name. And then for the option value, we're just going to pass in a reference to multiple. And then the length of this will just be the size of multiple. Just like that. And then if res is equal to socket, or if res is less than 0, then we have an error. So print out multiple client setup failed, and print out the integer as WSA get last error. Then we have to close the sockets listener and WSA cleanup and return 1. So that's that. So we have now set up the client or the server for multiple connections. All right, now I'm simply going to just say let's simply just delete the whole handle of client section. But we are stuff similar, or we're going to see similar stuff. So I'm going to simply just have a main loop section here. Now, instead of having a singular client, we're going to need several clients, and that's going to be a list of clients or an array of clients. Now, you may have read or you may have seen elsewhere that you can use multi-threading here and set up a new thread for each client, and I think that's what we did with Python. I think that was the first series in this channel. Python networking. But that is 100% unequivocally the worst option to use, especially for a larger server. Because if you have 1,000 clients, you're not going to have 1,000 threads. That's going to be a fucking clusterfuck. So what we can instead do is just have a list and iterate through that list in each of the iterations of a loop. So in this main loop, we're going to keep track of a bunch of variables. We're first going to have the set of clients. Now, the structure that you may not have seen before, probably have not seen before, but it's going to be fd underscore set. And this is going to be client set. So this is our set of clients. FD stands for file descriptor, by the way. Alright, then we're going to have some socket descriptors. So sockets, and we're going to have an array now. So socket clients, max clients. So clients is also going to need to be a macro that we'll define up above. Hashtag define max clients, and we'll just say 30. So this is an array of max clients. Now, you might be wondering, well, this is a set, but this is an array. So, well, why do we have two? Well, the array of clients will be used to store the information of the clients and just the sockets here. But the FD set itself will store these socket descriptors. So the file descriptors of the sockets. Alright, and then, sorry, I'm yawning a lot. Alright, so this is our set of active clients, an array of clients, and you'll see the difference when we get to the loop. And then we're going to have some information about the array. So int current number sockets is equal to 0, and maximum IDX is equal to -1. And then we're going to, similarly to the client, we're going to have an integer for the address length, or client address length. And then we will also have a structure for the client address. So struct sock address in client address. And then we'll also have a quit value. So character quit is equal to 0. Could use a type def boolean, but I'll just keep it simple for now. Alright, now before we get to the loop, we just want to clear the client array. So we're going to use memset. The pointer will be clients. The array, the value for each byte will just be 0, and the size, the number of bytes, will just be max clients times the size of socket. That's just the size of the array there. Now, this loop will be while not quit, so we will run and while we don't want to quit. Now, every iteration we're going to clear the set. So fd underscore 0. And the set will be a reference to read, or to client set. Or this should not be client set, this should be socket set. So rename this to socket set up there as well. Now the first socket in this set will be the listener. So add listener socket. So fd set. This adds something to a set. And we're going to pass in the listener as the socket to be added, or the descriptor of the socket to be added, and then a reference to read fd, or to socket set. And then we are going to iterate through each of the clients. Alright, so we add the listener socket, and then we're going to iterate through the rest of the sockets. So for integer I is equal to 0, I is less than max clients, I++. And then we're going to get the socket, so SD, oh, we did not set that up there. We are going to have some temporary placeholders, so socket SD and max SD up here. Placeholders. So the socket in the loop be SD is equal to clients at I. And then we're going to say if SD is greater than 0, then we're going to add the descriptor to the set. So fd set, and pass in SD as the descriptor to add, and then a reference to read, or to the client set. Alright. So this simply, I'm not sure I'm getting an error. Oh, it's socket set, not client set. Alright, good. Alright, so we're going to add the client to the set. Or add an active client to the set. And then we're going to get the maximum value. So that's what we're going to store in max SD up here. So we're going to say if SD is greater than max SD, then max SD is equal to SD. So that's just getting the maximum value of in the client array. Alright, so that's self-explanatory there. Now the reason why we need this is for when we call the select function. So outside of this for loop here, we're going to say integer activity is equal to select, and select will be selecting from 0 all the way to max SD plus 1. So so this first parameter is the number of file descriptors, or NFDS, the number of file descriptors. And since we go from 0 to the maximum value, and we want that maximum value to be the maximum descriptor value, that's why we needed to get that's why we needed to do this comparison every time we iterated through the clients. So get the maximum value. Then the set to read through will just be a reference to socket set. The set to write to will be null. Exception will be null, and then null for the timeout. So the last three parameters will just be null. So we're simply going to select active descriptors from the socket set from 0 to max SD. And then if activity is less than 0, then just continue. Now, we're going to determine which sockets have activity. So if fd, this is a function, so fd underscore is set, and then the descriptor we're going to pass in now is listener, and the set will be a reference to socket set. So fd is set. This function here returns a non-zero value when the socket that we pass in is an active descriptor, or it's indicated as descriptor. So if there's activity on this descriptor, then select will return a value. Yeah, it's simply if this file descriptor or this socket descriptor is ready to be read from, or it has some sort of condition that we need to tend to. That's what this function will return a non-zero value for. If the socket that we see activity on is the listener, then we want to accept the connection. So we're going to say client, or SD, is going to be equal to accept on the listener socket. We're going to call the accept function. The address will be null, and the address length will also be null. Then we're going to say if client is equal to invalid. Then we're going to say printf ever accepting, and print out an integer, which will just be WSA get last error, just like that. This should be if SD. So we get a socket descriptor from the accept function when we have activity on the listener socket. Then we check to make sure it's a valid one. Then we want to get the client information, which will be pretty much exactly as we did over here. So we can simply, I'm just going to go ahead and copy this because I really don't want to do this again. So we need to copy. Oh, so I'm actually not going to do that. But we need two placeholder or two variables above. Or we actually have them, the client address and the client address length. So client information. So get peer name, and the peer name that we want to get stuff from will be the SD, or the new client. And we're going to output to a struct sock address pointer conversion of a reference to address, so same as before, or client address. And then the same thing, we'll just pass in a reference to address length, or client address length. And we're going to print out. So printf client connected at %s %d, and we'll print out inet ntoa and address dot sin address as the string address, and then the port will be ntohs address dot sin port. Just like that. Or this should be client address, sorry. Alright, then we're going to want to send them a welcome message. So we can actually have two values up here, or two variables. We'll have a character pointer welcome, which is equal to welcome to the server, smiley face. And then we'll also have a character pointer goodbye, which will just be equal to goodnight as a string. And we can store the lengths of these as well. Sure, welcome length is equal to the string length of welcome, and ensure goodbye length is equal to the string length of goodbye. So since we don't want to have to call string length all the time, we can simply just store the values right there. So we're going to send a welcome message, and to do that, we're going to say the send result is equal to the send function. We're going to send to the socket SD, the client, and the buffer will be welcome. The length will be the string length of welcome, and the flags will be 0. What's up, Deval? I know I axed that name, but I think that may be how it's pronounced. I'm also probably late on this message too. Alright, so we get the result from the send call there, sending the welcome message. And then we can just once again say if send res, so if the send result does not equal welcome length, should use that over here as well. Then it did not send properly, so printf error sending, and print out WSA get last error once again, and then we can also shut down the client. So shut down the SD, which is the new socket, and then on both channels, and then close the socket. All right. Then we want to add so once we have sent the welcome message, we want to, and we have verified that we can send to it, we want to add to the array. So we are simply we're gonna figure out a few things. So if the current number of sockets is greater than or equal to max clients, then we simply don't want to have any more. So printf full, and then close the socket client, or SD. And we also want to shut it down on both channels. And then otherwise, else, if max IDX is less than max clients minus 1. I'm going to do this if statement in a second, but we're first going to do the else. So otherwise, we're going to scan through the list and say integer I is equal to 0 for an empty first condition Or wait, what am I doing here? No, this should just be for, I'm just going to simplify. For int I is equal to 0, I is less than max clients, I plus plus. Then if not clients at I, so if it's an open slot, then we're going to say clients at I is equal to SD, and then we're going to print f added to the list at index %d, print out I there, and then increase current number of sockets by 1, and then break. So now for this intermediate condition, we're simply just going to use the maximum index just as like a pointer, just to kind of simplify the insertion. I mean, you could simply just, I mean, I don't think this would matter. I mean, yeah, I'm just going to keep it simple. That's stupid. So just iterate through the list, find the first open slot, and then once you've found that, just insert the client there. Alright, so this if statement right here, if FD is set on the listener, if that passed, then we see that the listener is active. Now we can also have activity on the other clients, so we're going to loop through those clients. So for integer I is equal to 0, I is less than maximum clients, I plus plus. So we're outside of the if statement there, but we're still inside of the main loop. So we're going to iterate through each of the clients. If clients at, or if not clients at I, then continue because we don't have a client. Otherwise, we're going to say SD is equal to clients at I. And we're going to do the same if statement. So if FD is set SD and pass in a reference to client set. So if SD is an active file descriptor and it has some information that needs extracting or some activity that we haven't processed yet. Oh, it's socket set. My mistake. So if the current client has something or some information, we need to get a message from it. So we're going to use the receive function. So we're going to say the result is equal to receive. Receive on the socket SD. We're going to store the buffer in receive buffer, which we have not had, which we didn't allocate yet. But this is simply going to be the same thing as before. So character pointer receive buffer, or character receive buffer, an array of length buff len, and then we're going to say integer receive buffer length, or we can actually just use a macro, that's fine. Alright, so we're going to call the receive function, store it in receive buffer, and the length of this is just going to be the macro bufflen, and then 0 for the flags. Then if results, if the result, then we want to get the message, or print out message. So we're first going to set the terminator character, so buffer at res is equal to a \0. Where once again, result is just the number of bytes that were received. And then we're going to say printf received. And we'll just print out the string. And then we also want to do test if it's the quit message. So test if quit message, or quit command. So once again, if not mem compare, we're going to say compare the received buffer to the / quit, and 5 times the size of character. So once again, we want to compare just the first part of the other buffer, and then we're going to say quit is equal to true, and then break. Or quit is equal to not 0. And then otherwise we want to echo the message. So we're going to get the send result is equal to send to the client, to the socket SD. We're going to send a receive buffer back with the length result and 0 for the flags. And if send result is equal to socket error, then printf send fail or echo failed. And then we're going to shut down SD on SD both, close the socket, set the socket at the current index. So clients at I is equal to 0, and then say current number of sockets minus minus. Or there should be current number of clients. I'll just change the name to make more sense. Did I miss a curly brace somewhere? Or did I have too many? I think I had too many. There we go. Alright, so if the send result was a socket error, then it fucked up. Alright. Now else, in regards to the if statement about if the result is greater than 0, and else we received a closed message. So we're going to get the peer name, and then we can actually just copy the one from the connection. So get the client information and print it out. And then we can just change this to client disconnected out. And then we're simply going to do the same stuff as if the message sending failed. So shut down SD on both channels, close the socket, SD clients at I is equal to 0, and current number of clients minus minus. Alright, and then close there. So then we have removed that. Alright, so now that's pretty much the entirety of the main loop. Let's now, let me just check something real quick. Oops. How long have we been going? 131, alright, that makes a bit more sense. So outside of the main loop, let's go ahead and determine what we should do at the end. So what we're going to do is we're simply going to disconnect all the clients. So we're going to say for integer I is equal to 0, I is less than max clients, I++, and if clients at I is greater than 0, then we have an active client. We're going to send something. We're going to say send result is equal to the send function, send to the client. The buffer to send will be the goodbye message, and then we're going to say goodbye length 0 for the flags, or this should be clients at I, and then we're going to shut down the client. So shut down clients SD both, close the socket on the clients at I. Oh my god, I'm an idiot. I was wondering why shit was screwing up. I'm an idiot. Oh my lord. All right, and then clients at I is equal to 0. Holy crap. I mistyped a variable earlier when I was testing this, and it was screwing up with this shutdown. So now this makes a lot more sense. All right. So once we're done with the loop, we want to disconnect all the clients. Then that is pretty much the main loop. That's done. There. We can put this in the cleanup actually. All right. So yeah, let's go through this once again. So everything that we have above the main loop is the exact same as before, except we have set up the server socket now to handle multiple connections by activating the reuse address right here. So it allows local address reuse. Now we set it as a listener. I'm just recapping there. That's what we did before. Now for the main loop, we have a bunch of variables. We have a file descriptor set, and this set will return true for if something is in the set, only if the descriptor, file descriptor, socket descriptor, is activated. So if there's some information that we can read from it or write to. In this case, we're going to be reading from the clients. And we're going to have an actual array of the clients that will be permanent no matter if there is new information from that client. We're going to have two placeholders here, and then we're going to have information about the array. Then we'll have placeholders for the client address, and then quit value for the state. Alright, and then quit is the server state. Or I should actually make this running and make this a not zero, and then the while loop should be while running. And then when we receive a quit message, we should make run equal to 0. All right, good. So then we have our buffer for the messages, and then we have two placeholder messages for the welcome and goodbye message. All right, then we clear the client array just to make it there, and then for the loop, we take the file descriptor set and clear it because there may be stuff left over from the previous set or the previous iteration. Then we add the listener socket because that's always the first socket. And then we add all the active clients. So all the clients will be in the set, all the sockets, the server, and the clients. They will all be in the set. However, they will not be active. We will not get them in FD is set unless they are active. Alright, so then this activity, or this select function here, will examine all the descriptors in the socket set from 0 to max SD. This bound is not inclusive, so that's why we do a +1. And if this is less than 0, then we have no activity, and continue. Otherwise, we're going to say if FD is set on the listener, so we need to determine the sockets that have activity, and we're going to start with the listener socket. If the listener socket has activity, so if there's something to be read from, that means that we need to accept the connection. So we call the accept function, determine if it's a valid socket. Then we get the client information printed out. Then we send a welcome message to that, which is just the welcome message here, do all the validation, and then we add it to the array. and we do a bound check here as well. Then we're going to iterate through the and if a client has activity, so determine if client has activity, and if it does, then we have a message to take from it. So if get the message, we get it from the receive function. If the value is greater than 0, then we have to print a message. And we can also have a quick command, and then we echo the message back. And if we have an error, we're just going to shut down the client. And then otherwise, if the value is less than or equal to 0, then we're going to close the client out, remove it from the array, and all that jazz. And then for the cleanup, the only other thing that we're doing is we are disconnecting all the clients. That's just the next thing there. All right, so let's go ahead and test this out. So we first have to change the run command to take the main multiple file, so the second source. All right, so run this, accepting on that IP there. Perfect. All right, so let's load home. All right, so we have accepted a client there, added to the list at index 0. Let's open up another one. Added to the list at index 1. Load another one, added to the list at index 2. Perfect. Let's type something out. Hi. Same stuff. We receive the message and then echo it back to the client right here at index 2. I know you guys can't see the PuTTY screen, but you gotta trust me here. All right, then let's try disconnecting the first clients here. So close the session, client disconnected. And let's open up another one, and it should add at index 0 because that's the first open slot. So we have this here. Now let's send the quit message. So we'll just say hi, and then quit. Perfect. Fuck yeah. Awesome. All right, so shutting down good night. All those clients just went away like that. Before, what I was doing was I mistyped. I didn't have the indexing into the array, so I was simply just looking at another placeholder that I had, and it was just abruptly shutting down, so that I was getting like a server or hosted border connection, not a clean close. However, let me try doing something here. All right. I just want to see if we're getting the home, the goodbye message. Oh shoot! Oh, I am an idiot. I am an idiot. Give me 2 seconds. Oh, no. Give me 2 more seconds. All right. Open here, /quit. Good night. Perfect. Connection closed by remote host. Which is good. That's a clean close. And then we see the good night message right there. All right, so let's open up a bunch of these. Let's first let's decrease the limit to like 2. So I'll say max clients is 2. So let's run this. Do PuTTY, PuTTY, PuTTY again, and you'll see that this last one connected because we accepted it, but we say it's full. So we just we close the connection. So okay, inactive client, cannot do anything. Let's do this. Quit message. And we get a good night and good night on both the clients before they go inactive. Which is fucking perfect. Alright, so I am extremely happy because I fucked up when I was testing this. And stuff works now, which is awesome. All right. So yeah, that is that went by extremely fast, but it's now 1 in the morning. And so yeah, that is first part of our Winsock challenge. I think we'll be doing clients next time. And we may also put this into a chat application. Maybe some HTTP, I don't know. We'll figure stuff out. But I did it in C, or we did it in C, which is awesome. Because integrate this with all the other work in C and C++ that we've been doing with the math library. Maybe we can look at this in OpenGL, which would be something, that could be honestly very fun to look at, if we want to do that. But who knows? Maybe we can look at that at some point. But yeah, so I hope you guys learned something today. I definitely did in doing this, because I've done Winsock before, but I pretty much only read a tutorial and then said fuck it, because I didn't understand it too well. But this time I kind of took a deeper dive into it, and now I'm actually going to pay attention to polishing the code, making sure it looks good, and we'll work more on this. But yeah, I think that's a good place to stop for now. Yeah, next time we'll be doing clients, and who knows from there. So, hope you guys enjoyed, hope you learned something, and I will see you guys in the next stream, which could be non-OpenGL, or non-programming. I might do, I don't know what I'll do, but I do need to give you guys a fucking update on where I've been. I'm being so dramatic about it, but yeah. Also, before I forget, I don't know if you guys, I don't want to brag or anything, but thank you guys so much for 1,000 subscribers. It's really fucking cool. But yeah, I'll also be talking about that in another stream at some point. But anyways, I will see you guys next time. Take care of yourselves.